topic for today's discussion is simplification of grammars. We have already discussed what a grammar is, how we can classify grammar, that is the Chomsky hierarchy of grammars in our previous lecture. Chomsky classified the grammar into 4 types, type 0, type 1, type 2, type 3. In this lecture, we will focus on simplification of grammar. Basically, we will focus on type 2 grammar, that is context-free grammar, simplification. So, whenever I need to simplify a grammar or a context-free grammar, I need to follow these 3 steps, that is removal of lambda production, removal of unit production, removal of useless production. Now, in order to carry out these 3 steps, I should know what is a lambda production, what is a unit production, what is a useless production. So, let's briefly analyze and study how I can remove individually these 3 productions. Removal of lambda production. Now what is lambda production? Any production of the form A implies lambda. That is, on the left hand side if I have a variable, right hand side I have a lambda, then this kind of production is a lambda production. Now basically whenever a CFG is not generating a lambda in its language, so I can remove lambda productions from that particular CFG. Henceforth, I need to simplify that grammar. So the steps followed in that case is removal of a lambda production. So this is a lambda production. In another scenario, if I have a case where I have a variable A on the left hand side and on the right hand side I have a lambda that can be encountered in 0 or more steps. That is, from A if I have a B, then B tends to lambda. Then therefore I have written a star here that in any 0 step or any more number of steps, if I can reach a lambda, then this variable is said to be a lambda production. Now, consider an example. If I have S implies A S1B and S1 implies A S1B slash lambda, then directly I can see here that the lambda production is S1 implies a lambda. Now I need to remove S1 implies a lambda. How it can be done is, I have to first copy the same set of production rules into my new grammar, that is this. The second step which I need to follow is that since S1 implies a lambda, so whenever and wherever a S1 occurs in the right hand side of any production rule, in that case I have to put a lambda over there. So that means A S1B as it is in my new production. As well as I have another production, if I put a lambda in place of S1, I am left over with A and B. So I have a new production AP here. Likewise, for the second production rule, if I put a lambda here, I have a AB here, so I have a AB here as well. So lambda production is removed in this case. My equivalent grammar is this. Fine. Now, the second thing is removal of unit production. Now, what is a unit production? Whenever I have a production of the form where I have a single variable on the left hand side as well as a single variable on the right hand side, that is a form A implies a B where A, B are variables, then this kind of production is referred to as a unit production. Now, consider an example of the unit production. If I have a production rules in a grammar like this, now first we will identify what are the unit production here. S implies B can be directly seen, so I have written S implies B here. B implies A can be directly seen, B implies A is written here. A implies B can be directly seen, A implies B is directly written here. Now see, S implies a B, B implies a A. So S also implies a A, I have written here in 0 or more steps. So in 2 steps I am reaching from S to A. So this is also lambda production. Now, unit production, sorry. So we need to remove these unit production because these are just a wastage of time. Whenever I am having unit productions, these just increase my number of derivation steps. So henceforth I need to remove these unit productions. First of all, what we'll do, the same scenario in the previous one. Here also I'll add another production rules here. AA I've added in my new set of production rules. I'll add BB here. I'll add A and BC here. So this are to be added. Now in order to remove these unit production, what I will do is substitute the values. Let's take an example. If I have S implies A, so in place of the S production rule, I'll write the values of A. So values of A are A and BC. Terminals, that means values of A in terms of its terminals. So they are generating A, capital A is generating small a, that is terminal, and BC. So in place of S, I have added what else? A and BC. Also S implies B, so I will write the terminal strings of B also. In this case, the terminal of B was BB. So henceforth I have added BB also here. So another example, let's say B implies A. I need to remove this. So in case of the production rule of B, I will add the values, terminal strings of A. Terminal strings of A are A and BC. So I have added A and BC in the production rule B. Now the similar A implies B, values of B is BB. So BB I have added in A production rule. Now union of these two give my new equivalent grammar, that is this. S implies AA is written here. S implies BB, S implies A, S implies BC, I have written here. Likewise for B and likewise for A is followed. So that means union of these two gives my new equivalent grammar after the removal of unit production. Last production is useless production. We can remove useless production. Now what is useless production? First of all, any production that cannot generate a terminal string or it is not reachable from a starting symbol. Consider a variable is production is useless if, consider this example first. S implies ASP slash A slash lambda. A implies AA. Now see this production rule. A implies AA. Here there is no terminal, so AA will go in repeatedly. It will substitute with AA. Finally, it will not have any terminal string. So when A cannot generate a terminal string, so S implies A. This production can be removed because here A is useless. A variable is useless because it does not generate any terminal string. Now, a variable is said to be useful if it is in any derivation. If it is involved in any derivation, so A is useful here. If it can be reached from a starting variable and it can generate a terminal string, then A is said to be useful. So what I will say in a gist is, a variable is useless if it cannot be reached from the start symbol or it cannot derive a terminal string. Consider this example. S implies A implies AA slash lambda, B implies BA. Now first of all see B. So you see the variable B. B is not reachable from S. So B is not reachable from S, therefore B is a useless variable. B is useless variable, so I can remove it, I can strike it off. So I am left with only S implies A implies AA lambda. A generates a terminal string, therefore A and as well as A is reachable from S. A is useful, so it is not removed. Only the removed variable is B. Likewise, consider another example. Here S implies AS slash A slash capital C. A implies A, B implies AA, C implies AC. C cannot generate a terminal string because I don't have a terminal over here. So C is useless. So I have removed C. So after removing C, I am left with these three. C is removed from here also. S implies C. C production is removed as well as S implies C is also. So C is not placed there. After removing C, I have the production rules of the form this. B is also not reachable from S. You see here, B is not reachable from S. Now B is not reachable, hence it is useless. So B is also removed. So I am only left with my production rules of the form this. Now this is the time to ponder or think whether which of in this particular grammar are useless production, unit production, and non-production.